I am making this video of Unit 5 Systems Test Review. This is to help you since I will not be available during class, going to a conference. So I promised a video and I'm going to do my best to make it as easy as I can and help answer any questions you have. Please also check on Canvas. There should be copies of solutions and videos there posted that you can go back and use to help you study for the test. Number 1, the functions are graphed below. What is the solution? Remember, even though this is technically not a system solution that we've been doing because we've been doing two equations that make straight lines, a system is solved where the two equations cross each other. So if you look closely, this one crosses right here at the blue point. So I just have to make sure that I know what my solution is. And if I look closely, it says, what is the solution to the equation? So it looks like if I go over here, over 1, over 2, up 1, 2, 3, 4, that's actually the point 2, comma 4. Looking at the answers is basically just wanting the x answer, which of course is 2. So number 1 is C. Number 2, which one is the solution to the linear system? There we have a straight line, and I think we can see that we actually cross right here at -1 and up a 0. So -1, 0, C is correct. Number 3, which inequality is represented by the graph? So let's remember a few things. If it's less than with an equals, or if it's greater than with an equals, then it's going to be a solid line. Okay, solid. If it's just less than or just greater than with no equals, it's going to be a dashed line. Okay, if it's less than or less than equals, I'm going to shade. That's less than, so I'm going to shade below the line. If it's greater than or greater than with equals, greater than would mean I was going to shade above. Okay, so this is what we need to remember. If at any time we divide by a negative, ding, 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 warning, 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 warning. I hope those warning bells go off to remind you to flip the sign. That would be only if you divided or multiplied by a negative. So I'm going to look right here and I'm going to notice that that's +4. I also see that my graph goes downhill, so I should be able to reason that that's a negative slope. And if I check carefully for perfect points, I see one right here, I see one right here. So it looks like I'm going down 2 over 1, down 2 over 1. Down 2 over 1 would give me a slope or an m value of -2. So if I touch at +4, and now I'm looking at here, I'm shaded below that point. So if I'm shaded below that point, that's less than. That is a solid line, so it's less than or equals. So it's less than or equals, here's my y, here's my x, and I'm going to put my slope, -2, +4. So I need to see which one of these is going to create -2 with x and +4, and also have the equals. This does not have equals, so I can discount. A is not even going to be considered. Let's go check B. I need to move my x to the other side, and I'm going to put it right in front of the 4, and if I do, I get y less than equals. That's going to become -2x when it moves sides. That's +4. Well, first try. B is the answer I was looking for. Number 4, which graph is the solution? Which graph is the solution? Now, I happen to notice that I do need to change it. It's easier for me if I change it to y equals. So if I take x over here, it's going to become -x, but I also have a -2 with y. So I have -2y. Right now it's still less than or equals. I've brought that x over, so now it's -x, +4. I do need to divide by negative. Ding, 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 ding. Did you hear we just divided by a negative. So it's still going to be y, but now I'm going to flip that sign to be greater than or equals. I have to do that. Negative divides by negative, that's going to be 1/2 with x positive. Positive divided by -2 is going to be -2. So that kind of gives me the top equation. Okay, had to do a little work there. So if I move x over, this is going to be a lot easier. If I just move x over, I already have y. It's positive, so sign does not change. And it's going to be negative x plus 3. Now, I have to be sure I find the one that's shaded, and I'm looking for the overlapping shaded region. So they're going to be shaded different ways. So this one's going to start at negative 2. So I think negative 2, it's kind of hard to find. Right here's my x-axis, or x and y. So it does cross at negative 2. The other one crosses at positive 3. So at least that one does have negative 2 and positive 3. This one looks like it's crossing. It's really hard. That's really dark. Really dark. Let's see this one right here. I think they're all the same. So that one's going to cross at negative 2 and positive 3. I'm actually going to throw D out. Why would I throw D out? It's not even shaded. So I know my answer is a shaded region. And then there will be something shaded. All right. I'm going to look at this one right here. It says positive 3, but that's a negative x, so it's going to go downhill. Okay. This is a negative 2, and it's going to go up 1 over 2. That one's looking pretty good. So just have to check. This one should be shaded above, and it is. Okay. But then the other one's also shaded above too, and it is. So that one right there is shaded above. And so I had given you guys highlighters, and I had told us to highlight the answers region. So it's looking like A meets everything that we need. Okay. This one is not shaded in the right place. This one's shaded below, which would be less than, and both of my signs are greater than, greater than. So that one's shaded in the wrong place. A is the best. Okay. These are not easy. Take your time. How many solutions does the linear system have? Well, it's set up to eliminate. So I'm going to approach number 5 by elimination. And so when I solve number 5, I'm actually going to look and see. I know if I have a positive 6, I need a negative 6. So if I multiply everything in the top equation by, let's just say, negative 2, then I could actually make it be negative 6 on top. So I'd have negative 6x minus 4y, negative 20. The bottom equation I am not changing. 6x plus 4y equals 15. Now when I add these together, 6x's cancels. Wow. What happens to y's? Negative 4y, positive 4y, y's cancels too. So when they add up to be 0, but negative 20 and 15 does not add up to be 0. That adds up to be negative 5. And what happens is that is a false statement. 0 cannot be equal to negative 5. So if it's a false statement, that means that we actually have, guess what? No solution. Number 6, how many solutions does this one have? I'm going to take the same approach. I'm going to basically say, well, I need a positive, I got a positive 9, I need a negative 9. So what if I multiply this by 3? Multiplying everything by 3, I get negative 9x, positive 3y, and positive 27. The bottom equation is 9x minus 3y, negative 27. Interesting. X's cancel. Y's cancel. Positive 3, negative 3. 27's cancel. Positive 27, negative 27. But this time I actually get 0 equal to 0. Is 0 equal to 0? Yes. This is a true statement. And since that's a totally true statement and I do not solve for either x equal an answer, that tells me I have so many answers that I can't write them all down. I have infinitely many answers. Number 7, how many solutions does this one have? Okay. Well, I have seen 2 examples. If my x's and y's both cancel, just like they did up here, then now I'm looking at, possibly either no solution or so many, infinitely many. If the equations turn out to be exactly the same like they did number 6, then I'm looking at infinitely many. But if I end up getting something where I can solve for either an x or a y, I know I'm going to have only one solution. In these system of equations, we should never have 2 solutions. Yes, You do have an X and a Y, so there are two numbers, but that's really 1 point on a graph. So it really is one solution. The X and the Y go together to make the one solution, so you actually won't have two. So I'm going to check this out. I happen to notice that positive 2y, negative 2y, that's going to cancel. So I'm actually going to get 11x is equal to negative 11. I don't even need to do anything else. I actually have an x and I have a number. I know I can solve for x. So I know this is going to have one solution. Okay, so remember, I did not get any zeros. So I know it's not going to be no solution, and I know it's not going to be infinitely many solutions. This time I got an x and a number. I know I'm going to get an answer. This one's a little tricky. Read carefully. What is the y value? So I don't necessarily have to solve for both. I can only solve for y, and I'll be good. And looking at number 8, it looks like it's set up to substitute. Notice it says x equals. So I'm going to let 3y minus 1 be the blob. So it's like substituting into a game. I'm going to put 3y in place of x. So every time I see an x, I can put 3y minus 1 in its place. I have to be careful because there's a subtraction, and I don't want to miss the subtraction. So it's going to be subtract. I'm going to use parentheses, equals 11. So I'm going to put 3y minus 1 in there. Now remember, treat that as though it's negative 1 and multiply. So I'm going to get 5y minus 3y plus 1 equals 11. Take the 1 to the other side and subtract 1. These two are already on the same side, so combine them. Remember, here's where I separate my problem. So I end up with 2y equals 10. Divide the 2. Y turns out to be 5. B is correct. I don't have to solve for x because it only asks for y. Which ordered pair is the solution? Now, you can solve this. You can also actually check the answers. If you wanted to go to this trouble, you could say, you know what, that's an x and a y. If I put x here and did the first equation, would it be true? But I also have to put, I would also have to put the 2 in for the x here, and the 1 in for the y here, and the second one would also have to be true. That's a lot of work. So probably by the time I would check all 4 answers, x and y, in 2 equations, that would be 8 times I would have to check. I could just have this thing solved. That's going to be my blob because it says y equals. So everywhere I see a y in the top equation, I'm going to put x minus 3. Negative x minus 3. So negative x minus 3 minus 2x equals 3. Miss Jessup likes to always substitute in with parentheses. Since it's in the front and there's no number to multiply by, if I really, really wanted to, I can actually drop the parentheses. So here's where it separates my problem. Everything that's not an x goes to the other side. So I'm going to have 3 plus 3. I'm going to get 6 over here. I have negative x and negative 2x. Those are on the same side. They're alike. So I'm going to add. I should get negative 3x. Divide negative 3. X is equal to negative 2. Do I have any answers that say negative 2? So A is out, C is out. So now I've narrowed it to B and D. To get your second answer, substitute the x answer back up to either one of the equations and solve for y. I would like to suggest you go to the easiest one. This one already says y equals. So if I can just put this number right here, I can get my y answer. Now I got to be careful. I have a negative in front of x. So anything like x comes out, but I kept parentheses there, minus 3. So now I'm going to dump the negative 2 in there. So if I dump negative 2 in there, I end up with a negative of a negative. Subtract a negative, add a positive. So it ends up being 2 minus 3, and 2 minus 3 is negative 1. So I know the answer is negative 2, negative 1. D is correct. Which point represents the solution of the system? 9 was set up to substitute. 10 is set up to eliminate. So we're going to do elimination. So remember, when you eliminate, you're trying to get your x's are lined up, your y's are lined up, your numbers are lined up across the equals. So they have to be kind of set up very much that way. I need to have a positive 5 paired up with a negative 5. So if I do that, I'm going to multiply everything on the bottom by negative 5. I'm not going to do anything to the top equation. So 5x minus y equals negative 17. On the bottom, everything gets multiplied by negative 5. So now my x's are going to eliminate. Negative 5 and negative 5y is positive 25y. And negative 5 and negative 13, that's going to be a positive. And 13 times 5, I think, is 65. So I had a little bigger numbers there. Now my x's did eliminate. Negative y and 25y, that's going to give me 24y. 65 minus 17, is that 48? I think that is 48 positive. Divided by 24, y turns out to be 2. So I have a 2 for B and D. So I'm going to narrow my choices, and A and C don't work. Now I got to see, is my X answer going to end up being 3 or negative 3? So I got to be careful with my numbers. I'll take this back up to either one of the original. It does not matter which one you use. I'm just going to go to the first one, 5 times, and I'm looking for X minus the Y answer of 2 equals negative 17. Negative 2 goes over here and becomes positive 2. So I end up with 5x is equal to negative 15. Divide by 5. X turns out to be negative 3. So it's 2 for y, negative 3. So B is correct. Number 11. What is the solution for this linear system? I'm just going to keep doing this again and again and again. You have to be able to solve systems. It's about just taking the time and pushing through and getting it done, because that's what we need to do. 4 does not make 3. 3 will not make 4. So I have to think of what will multiply that will give me those numbers. So I'm going to end up multiplying, let's say, this one by 3 and this equation by 4. Now, it depends on what I want to eliminate. I think I'm going to eliminate the y's. And if I look closely, I already have a positive with 4 and a negative with 3. So I can just leave it with 3 and 4, and I don't have to make one of them extra negative. So I'm going to multiply. Everything on top is multiplied by 3, so 12x plus 12y equals 12. Bottom equation, everything is multiplied by 4. 12x minus 12y. 27 times 4, it's 108. Okay, I think it's 108. So now we're going to add the equations. Add the two equations, adding these. So when I add 12 and 12, I get 24x. These add up to be 0, so they're canceled. And when I add up these, I get 120. Divide by 24. Divide by 24. X turns out to be 5. Now, if I look, I have 5 for X, and 2 of my answers, B and C, are out of contention. I got to go back and put my X answer in for wherever I want. I just simply probably will go to the first equation. I just typically go there. It's 4 times the number X plus 4y equals a 4. And, of course, that number turns out to be a 5. So I get 20 plus 4y equals 4. Subtract 20, take that over there, so you have to subtract 20. 4y is equal to negative 16. When you divide by 4, y turns out to be negative 4. So now I know the answer is A. One plane's traveling toward the airport following a line. Another one's traveling toward the airport following a different line. What are the coordinates of the airport? So that would be where the two planes meet, and of course they're probably going to meet at the airport. In looking at the two equations, I am set up 5x and 7x are lined up, 7x and 14x and numbers, set up to eliminate. I notice that 7 and 14, I have a positive 14, so if I can make that a negative 14 by multiplying everything up here by negative 2, I'll have it. So I'm just going to recopy this equation. 7x plus 14y equals 42. I'm just going to recopy that. Now I'm going to multiply this equation and copy it down here above it. Negative 2 times 5x is negative 10x. Negative 2 times 7y is negative 14y. And that's going to be negative 30. adding, remember, add your equations. Negative 10x added to 7x is negative 3x. Adding negative and a positive 14 gives me 0, and adding negative 30 and 42 gives me positive 12. Divide by negative 3, negative 3. X turns out to be negative 4. I have two choices. A and C are negative 4, so I'm going to cross out B and D right away. Now, I'm going to go put this back into one of the original equations. I typically will usually go to the first equation, so I'm going to put a 4 in for X. So I'm going to put a 4 in for X. So 5 times 4, negative 4, plus 7y, kind of run out of space here, Penny. It's going to be negative 20 plus 7y is equal to 15. Bring the negative 20 over here. It's going to become positive 20. So I get 7y is equal to 35. Dividing by 7, y turns out to be 5. So now it's negative 4 and positive 5. C is correct answer. Hopefully, while we're reviewing these, it's coming easy to you. You're kind of saying, okay, yeah, I remember doing that. I remember doing that. 13. Now, I notice in 13, it's basically saying which system of equations. Like, I don't even have to solve this system. I just have to figure out which one is the best. The community theater is a capacity of 600 persons. Adult tickets are $4. Children's tickets, $2. The theater wishes to earn $2,000. Which system of equations could be used? This is one of those money, money, money problems. And when I say money, 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 I mean one equation is going to have a money number in it. So adult tickets are $4. I need to use $4. So it's going to be $4 times every adult ticket. See, children tickets are $2. So 2 times every child's ticket. And then how much money? So it's money, money, and more money. So I want to equal 2,000. Okay. And I'm looking. 4A plus 2S, student tickets. I guess they used S for student. I used a C for child. Same thing. That one says equal 600. And I have to equal, I think, $2,000. 2A plus 4S. Nope. Should be a 4 with A. So that one's out. 4A plus 2S, this one's looking good, 4A plus 2S. So I've narrowed my choices to C and D. Now, the other equation will just be number, number, number. I don't want any money. So I need a equation that's going to have 600 persons. Well, if there are however many adults and however many students, then I need the total number of all of those people to be 600. So A plus S. I don't need the 4s and the 2s anymore. Only one equation has money, money, money. So D is the only equation that has the 2 equations that are the right ones. Okay, so we only had to set up 13. It did not ask me to solve. I was able to pick out the right correct equation. All right, number 14. Shauna makes money selling bracelets and necklaces. Each bracelet sells for one price, each necklace for another. I'm going to use one equation to write the first, one sentence to write the first equation. 10 bracelets. 16 necklaces, 389. 16 bracelets, use the second equation, or second sentence, second equation. 16 bracelets, 10 necklaces, $365. All right. Now I notice that I have a 10 and I have a 16. Not going to be super easy to do this one. Probably I would not see this one unless I had access to a calculator. But if I multiplied this one by 16 and I multiplied this one by 10, I would end up with 160. I just need to make one of them be negative. So I'll just randomly let the bottom one be negative. So I'm going to rewrite both of these equations. So I'm just going to rewrite under here. Okay, rewriting the top equation. 6 times 10 is 160. 16 times 16. Grab your calculators. I think that's 256 in. 16 times 389. You have to have a calculator. 6,224. That is not going to be easy if you just have to do it by hand. Now I'm doing the second equation. Let's do the second equation. 10 times negative 10 times 16 is negative 160. Negative 10 times positive 10 is negative 100. And then negative 10 times that one, 10 multiplied by 10 is easy. You just basically add a 0. So I'm still going to have 365, add a 0, and it should be a negative. Now I'm ready to add because I have been using elimination. I add up the B's and I made them cancel. So the necklace is actually what I was looking for. How much does each necklace sell for? 256 and negative 100 is 156 with an N. Then you need to grab your calculator. 624 or 6,224 minus 3650 is 2574. Divide by the number in front of N. I got a decimal. Each necklace is $16.05. Since this is money, that would be $16.50. 50 cents. Okay, number 15. I'm going to try to make sure I focus my attention. These are the problems that I'm probably going to see on the exam because these are the ones that they're going to want me to write. I'm going to try to write the first question, first sentence from the first part. 2 times Antonio's age. 2 times Antonio's age is going to be 2A. Plus, that's an add sign. 3 times Sarah's age, 3S. Equals. And on the other side of the equals is 34. Okay. Sarah's age is. Okay. Now I've got a little, let me clean that up right there so it's a little clearer. Sarah's age is. So I'm going to say S is. That's an equals. 5 times Antonio's age. 5 times Antonio's age. There is no plus or minus because it didn't say anything about adding or subtracting. Now this is set up to substitute. Everywhere I see an S, I'm going to put 5A in its place. So right here's my S. One equation is substituted into another equation. So I have 2A plus 3 times, and I'm going to substitute 5A in place of S. S comes out, 5A comes in, just like in a basketball game. Multiply right here first, get rid of parentheses. I'm going to have, I'll come up here, 2A plus 15A equals 34. Now these are alike. They both have an A and they're both on the same side. So I have to recognize that 17A's is 34. Divide by 17, I end up with 2. So Antonio is 2, which is kind of sad because I really needed Sarah's age. But it ain't hard because look right here. If Antonio is 2, only 2 years old, I'm going to put 2 right over here. What's 5 times 2? Sarah is 5 times Antonio's age. Well, if Antonio's 5, Sarah is 5 times 2. Sarah is 10 years old. And she's the one I really wanted. The sum of Elliot's age, okay, the sum, I'm not adding. Elliot's age, so I'm going to use an E for Elliot. And twice Zane's age, I'm going to put a little crossbar for the Z, is 44. Now it says the difference, that means I'm going to subtract. Twice Elliot's age, so that means he was mentioned first, so he's going to go on the left of the subtraction sign. And Zane's age, now okay, Zane's is -2. Okay. This one's set up to probably eliminate. You could change it for substitution if you chose to, but I'm going to eliminate this one. I need Elliot. So if I can actually get rid of Zane, then I'll solve for Elliot first, and I won't have to actually solve for the second one. So if I'm smart, I'll try to get rid of the Z. Well, if this is a positive Z, I need a -2. So I'm going to multiply this by -2. So the top equation, I'm just going to recopy. E plus 2Z equals to 44. Bottom, I'll multiply everything by -2, so it's -4E. Wait a minute. I don't need to multiply by negative. Sorry, my bad. I'm a little tired right now. 4E, because that's already negative, minus 2Z, and then I have -4. So let's add. The Z's cancel, which is what I wanted. 5 E's, and 44 minus 4 is 40. Divide the 5. Elliot is 8 years old. Got his answer first. He's the one I wanted. Good to go. 17. I can see there's daylight coming ahead. We're finishing up. 17. The sum of two numbers. The sum of two numbers. I'm going to use the first equation to write my first sentence, write the first equation. The sum of two numbers. I don't know what the two numbers are, so I'm going to use x and y. Sum. Sum means I'm going to add those two numbers. So it's going to be x plus y is 8 more than. Okay, 8 more than implies that there's something there already, and you're going to have 8 more than whatever that is. So I'm going to go to the end and put 8 more than plus 8. Twice the first number. Well, x came first. I'm going to let that be my first number, so twice x. Now, this is my first equation, but I want to clean it up a little bit. I recognize that I have an x here and an x here. I'm going to bring this x over here to this other side and get all my x's together. Now, if I bring it over, it's going to subtract x. So that's going to give me an equation that's simplified to y equals 1x plus 8. Actually made it a little bit easier. So I did have to clean up the first equation. Now, let's focus on the second sentence and see if we can get our second equation. Their difference. When it says difference, I know I am subtracting. Their difference. We're implying there is back referring to the two numbers. The two numbers difference. So again, x minus y is, okay, so equals 4 less than. 4 less than. Remember, 4 less than means I must be wanting to take 4 away from something that must be in front of it. So I'm going to kind of leave that space there. Twice the second number. Which one is the second number? Well, we let x be the first number, so y must be the second number, so 2y. Now, just like the first one, this one is not cleaned up, so we're going to clean it up. I think I'm going to take, in this case, I don't want the negative. I want to get rid of that. So I'm going to add y. So when I do, I get x equals 3y minus 4. Now, both of these are set up as x equals and y equals, so probably the best thing to do is to do substitution. So if you do substitution on this problem, you have a choice. You can substitute whichever equation you want into the other. Well, I'll just pick the first one. Y is the same as 1x plus 8. So in the other equation, y is going to come out and 1x plus 8 is going to go in. So x is equal to 3 times y comes out, x plus 8 comes in. I still have to subtract 4. To get rid of parentheses, multiply, multiply. So I'm going to get x minus 3, x equals 3x plus 24 minus 4. I need all my x's together. So if I bring this x, here's my sign, over here, negative 3x. These two numbers are already just numbers. They're already on the same side. So 24 minus 4 is 20. X minus 3x is negative 2x. So by the time I divide by negative 2, I'm getting an x answer of negative 10. Negative 10. So it's possible to have a negative number. All right. Now I still need to find the second number. So if I have my x answer, I'm going to put this x answer back up here to either one of the first two equations. And if I look closely, I'm looking for y. So I'm probably going to go to the one that says y equals, because it's already simplified for y. So I'm going to put negative 10 right there. So to get my answer for y, negative 10 goes in place of x plus 8. So my y is negative 2. So it just asks for the two numbers. You don't have to list at a point. So my answer is negative 2 and negative 10. Now I did some writing. I needed more space, so I kind of bled through or used up some space down here. I'm getting ready to erase. The beauty of having a video is you can go back and rewatch that part. Go back and pause it if you want to write that and you didn't get it. You can just pause it. 2 questions to go and we'll wrap up this part of the review. Be sure you finish the cut and paste activity. You can check some materials that are posted on Canvas that can help you. The length of a rectangular garden. So we're talking about it, and I know it's using the word perimeter. So just to review real quickly, we know that if we have a rectangle, the longer one is the length, the shorter one is the width. When I'm talking about perimeter, I'm talking about walking all the distance around it. So I would walk 2 times the lengths and 2 times the W's, the widths. So I have to keep that in mind. So every time it talks about a rectangle, I have to remember, and it mentions perimeter, that's what I probably need to remember. Okay, first sentence is probably going to give me my first equation. The length of a rectangle garden, the length of a rectangle garden, so the length, I'm going to use L, is 3 yards more than, 3 yards more than. So it implies something's there already. It's going to be plus 3, 3 more is plus 3, twice the width. So 2 times W must have been in the front of that. Now it says the perimeter of the yard is 36 yards. So that's where we have to draw this equation. Well, we know perimeter is twice L and twice W, and now we know that the perimeter number is 36. So I'm going to put a number 36 in place of P. This one's set up to substitute, so this is my blob. Substitute in for L right there. 36 equals 2 times the blob L. L comes out. 2W plus 3 comes in. Plus 2W. Multiply, multiply. I get 4W plus 6 plus 2W. Here's my equals, which separates my two sides. I'm going to have to move some stuff and combine some stuff. W and W, those two can come together to make 6Ws because they're already on the same side. 6 needs to go over here, so I'm going to subtract 6 from both sides. So I end up with 30 is equal to 6W. Divide the 6 out. I get W is equal to 5. Now it says, what are the width and the length? So I also have to go back and get the length. I'm going to take this answer for W, for width, back up to either one of the equations. I can go to the second one or the first one, but the first one catches my eye because it's already got L, solved for L. So the length is going to be 2 times the width, which was 5, plus 3, which makes that length 13. So it says, what are the width and the length? So I could say the width is 5, the length is 13. Miss Jessup's just spelling it out because that's what it wants. It didn't say dimensions, it said length and width. Okay, just like the last problems, I needed more space, so I kind of just used it on down the page. But I'm going to erase. Again, the beauty of having a video, you can go back and pause it if you need to copy that down. The admission fee on a small fair is $1.50 for children, $4 for adults. On a certain day, 2,200 people enter the fair, and $5,050 is collected. So it kind of sounds like something maybe like Dixie Classic Fair. I think this is another one of those money, money, money problems. And I hope that these are something that you recognize and that you can do easily. I need one equation that's going to have a money number, money number, money number. So when I see $1.50, that's 1.5, and that's for children. I'm going to use a C. $4 for adults, and that's for adults. I'll put an A. And you can put the dollar sign in the first time you want to. And I'm wanting to make how much money? Money, money, money. So $5,050. The next equation should just be something related to the number of people. Well, the number of people that we wanted to come in was 2,200. So some children came in, some adults came in, and the total was 2,200 people total that came in the gates. All right, since it's set up, I'm probably going to eliminate. And does it say how many children and how many? So I need both answers, so it doesn't matter which one. Probably not going to fool with the decimal right now, so I'll just work with the 4. So if I have a positive 4, I need to multiply this by negative 4, which means the entire equation gets multiplied by negative 4. So Miss Jessup's just going to recopy the first one, 1.5c plus 4a equals 5,050. The second equation, though, is going to change to negative 4c, negative 4a. And the negative 4 times 2,200 is negative 8,800. This one you probably need your calculator. I'm praying you don't see numbers that large on your exam. Okay, $1.50 minus 4. That would end up giving me negative 250c. Okay, my a's canceled. And 5,050 subtract 8,800. Okay, it's going to end up being negative. And when you subtract, you end up getting 37 and 50. 3750. Now I'm going to divide by negative 2.5. That's the beauty of having a calculator. You can do these decimals for us. So the children, negative 37. Negative divided by negative is going to be positive. And when I divide that out, the children turned out to be 1,500. It's a lot of kids. A lot of kids like to come to the fair. Now, I do need both answers. So in this case, I'm going to take my answer for C, and I'm going to put it in the easiest equation. To me, the easiest equation is right here. So if I had 1,500 kids, how many adults do I need to add up to 2,200? Well, if you subtracted 1,500, you would find out that you need the adults total 700. 700 plus 1,500 would add up to be 2,200. So 700 adults, 1,500 children came to the fair. That concludes the test review. I hope this has been helpful, and I hope it helps you